All right, let's talk about discontinuity that we see in rational functions. I've started off with this example just to show the two different types of discontinuity that we can have in a rational function. I've given you a rational function here that's already in factored form, y equals x plus 3 times x minus 1 divided by x plus 2 times x minus 1. Now, first of all, if we consider this rational function and where it might be discontinuous, hopefully we would remember that discontinuity is going to happen whenever my denominator equals 0. Whenever I have a rational function, if your denominator is 0, that means that your function is going to be undefined and there will be discontinuity in the graph because you can't divide by 0. So if I look at my denominator here, in this first factor x plus 2, if x is equal to negative 2, that would make my denominator equal to 0. And so I'm going to have discontinuity at negative 2. Also at x equals positive 1. If x equals 1, that second factor is 0, and so my whole denominator would be 0. So at both of those numbers, we're going to have discontinuity in this function. Now you may notice if we look at the function as a whole that the x minus 1 factor is in the numerator and the denominator. And that means that they can cancel each other out. So let's see what difference that makes in the graph of our function. I've got the graph over here to the right. If you'll notice at x equals negative 2, right here we have an asymptote. That is discontinuity in the function. There's an asymptote on the graph. The function will never cross that vertical asymptote. But notice at x equals 1, we just have a hole. Because that factor canceled out with a like factor in the numerator, that means that we are still going to have discontinuity at that value of x, but it's only going to be a hole. We're not going to have the whole asymptote like we have over at negative 2. Just a hole in the graph at x equals to 1. If the hole was filled in, then what I have graphed here would really be a graph of x plus 3 over x plus 2, the simplified version of our rational function. And so that's what our graph looks like, just with a hole at x equals 1. So those are the two different types of discontinuity. Let's look at a couple more examples. In this first one, we have x squared minus 2x minus 3 over x squared minus 1. The first thing that we should do here is factor. So in the numerator, I'm going to have x times x, because that's going to give me x squared. And then to get 3, my only choices are 3 times 1. I want to get negative 2 in the middle, and so I'm going to make that 3 negative and make the 1 positive. Now in the denominator, I have x squared minus 1. That's a difference of 2 squares, and so that's going to factor to x plus 1 and x minus 1. So I have two factors in my denominator. Each of those factors is going to give me a 0 of the denominator, which will give me some type of discontinuity in my graph. For this first factor, x equals negative 1 will make that equal to 0. And for my second factor, x equals 1 will make it equal to 0. Now if I look at my rational function as a whole, I notice that there's an x plus 1 in the numerator and the denominator. Those can cancel out. And since that factor canceled out, then the 0 that I get from that factor, or the point of discontinuity that I get from that factor, that's just going to be a hole in the graph, or a point, just a point of discontinuity. However, the factor that remains, x minus 1, x equal to positive 1 is what makes that factor 0. That's going to give me an asymptote on the graph. And here's just a quick sketch of what this graph would look like. Notice at x equals 1 we have the asymptote, and at x equals negative 1 we have a hole. Let's look at one more example. Again, we're starting out with a rational function that's not factored, so we need to factor. In the numerator, I'm starting out with 2x squared, so numbers that multiply to give me 2x squared would be 2x and x. And then numbers that multiply to give me 3 would of course be 1 and 3. I want to get -5 in the middle, but notice my 3 is positive. That means that my signs need to be the same, so they're both going to be negative. And so if I'm going to get -5 in the middle, then I want to put 3 here and 1 here. That's going to give me -2x on the outside numbers, -3x on the inside, which will give me that -5x in the middle. And the denominator, x times x is x squared, and numbers that multiply to give me 6 would be 3 and 2, and I want the 3 to be negative and the 2 to be positive. Now if you notice on this one, neither of my factors in the denominator cancel out. So I'm going to have discontinuity at whatever makes the denominator 0. In this case, x equals 3 would make my first factor equal to 0. X equals -2 would make the second factor equal to 0. And neither of those factors are repeated in the numerator. Neither one factors out. And so that means that they're both going to be asymptotes at x equals 3 and at x equals -2. And so the graph of this function would look like this. Notice that we have an asymptote at x equals -2, and then also an asymptote at x equals 3. And for this graph, there's no holes because neither of the factors canceled out.